Welcome back, students. Today we will study about integral calculus, but I would just like to wind up differential calculus, which we have been studying from the past 2 episodes, by just giving you some practical real life as well as the kind of applications which we will be very frequently using in the syllabus of class 11. So just quickly see the applications. First of all, you are familiar with this term V average velocity. You have been studying it from class 9. Average velocity is change in displacement upon, this is rate of change of displacement, which is change in displacement upon time, isn't it? Now, if we apply limits as we have been doing limit, when the time limit approaches 0, or you can say the time slot becomes small, the time limit approaches or it becomes close to 0, then delta S by delta T. I told you in the beginning itself that delta S represents a big change in S, this represents big change in T. But when the change in T is very small, it approaches 0, then this term becomes equal to this term, which is ds by dt. How do we read it? We read it as small change in S with respect to small change in T. And we call it as rate of change of displacement with respect to time. And this is how we define instantaneous velocity. In the first episode, I told you what is the need for calculus, and there we discussed that it was the need to find out the instantaneous values, whether it is velocity or acceleration, maybe its power or its force, which created the need for calculus. So, in order to calculate instantaneous velocity, we have to differentiate displacement with respect to time. It is rate of change of displacement with respect to time. Similarly, getting on to instantaneous acceleration, you know average acceleration is change in velocity upon time. We call it big change in velocity upon time. And if we want to get instantaneous, means at a particular instant. Acceleration at a particular instant. Velocity at a particular instant. That can be given when we differentiate velocity. Now this big change in velocity becomes small change in velocity. And we call it rate of change of velocity with respect to time. So instantaneous acceleration is dv by dt, rate of change of velocity with respect to time. Similarly, power, we know average power is work done, rate of doing work. This is how you define power. It is work done upon time. This is big change, and when the time limit approaches 0, the same condition is applicable. Then it becomes dw by dt, means rate of change of work with respect to time, which is called instantaneous power. Then we have force. In junior classes, you have learned this expression that F is equal to delta P upon delta T. It is where P stands for momentum. It is rate of change of momentum. In 9th also you have learned this term. Force is the rate of change of momentum. But when this time delta T is so small that it approaches 0, then it becomes force equal to dP by dt, which is rate of change of momentum. Force is given by rate of change of momentum, instantaneous. This is the particular rate of change, or you can say that it is the continuous variation of momentum with respect to time. So these are some practical applications, and these formulae we will be using them time and again in class 11, where we will apply differential calculus in practically solving the numericals pertaining to instantaneous velocity, instantaneous acceleration, instantaneous power and force. Is it clear? So let's get on to the actual topic for today, integral calculus. Integration. Basically, this is reverse of differentiation, as I have already given you a hint in the episodes 1 and 2, that basically integration is going to be the reverse process of differentiation. Whenever we have to sum up, integrate means to add up, to sum up. Whenever we have to sum up the factors, there are basically 2 ways we adopt. Either it is integration or summation. You must be having a question in your mind. Then when we already have this concept of summation, which we have been using in the junior classes, what is the need for integration? So you need to understand that summing up is done with these methods, integration and summation. But summation is particularly useful when you sum up the values of discrete variables. Discrete variables. Whereas integration is used to sum up the values of continuous variables. In order to understand the difference, even though the example is slightly what you can say hypothetical, but you need to understand, like water flowing in a river, that can be taken as continuous flow, whereas the water packed in packets, water packets, drinking water, distilled water packets, that represents the discrete packets or discrete step size of water. One is continuous flow, where you have to maintain continuity, where you have to see the flow is continuous, you are marking each and every step. There it is integration, and when you are taking it in step size discrete units, then it's going to be summation. So integration, it has a symbol of this elongated S. It is used to sum up values of continuous variables, and summation, it has this symbol, you are already familiar, and it is used to sum up the discrete variables. Basically, originally, as we have already discussed in episode 1, if the original idea of integration came into existence when people wanted to calculate the area under a particular curve and x-axis. Suppose this is x-axis and the area under this curve. This area, if they are interested in calculating, if I am giving you this particular segment, you can easily find the area. Why? Because this is A and this is B. This length and the distance between these lengths, it is almost fixed. So you take the length into breadth and you get the area. But in situation like this, here you can see the side length, here it is long, at this point it is short, again it is rising. So the distance between A and B is continuously changing. So in that situation, if we have to calculate the area, as we have already told you, the Greeks, they made what you can say concept of breaking this area into infinite strips of rectangles, and tried to find the area of each rectangle and integrated all the areas of the rectangles to get the required area. That was the original notion of integration. Now integration nomenclature, how we write it symbolically. We represent it, be careful, this is an elongated S, you can see it here. A and B, I'll let you know about it. We write it as f of x. F is a function of x, and this is f is a function of x, and you have to integrate f with respect to dx. You have to integrate f, you have to integrate the function with respect to dx. Dx represents, yes, small bit of x. These small dx, they have to be added, and fx has to be integrated with respect to dx, and these are the limits. A and B are called the limits. This A is called the lower limit and B is called the upper limit. It tells you the variation range of x. Suppose here A is 2 and this is B is 5. Then your variation of A to B is from 2 to 5. Lower limit is 2, upper limit is 5. So this is lower limit, means from where the integration is starting and where is it going to end. So when we use these limits A and B, upper limit and lower one is called lower limit, upper one is called upper limit. And when you use the limits, you call it a definite integral. When we make use of limits, we call it definite integral. But we do not specify the limits. When we do not apply the limits, when we do not specify the limits, then we call it indefinite integral. Definite integral means when we apply the limits. Indefinite integral when we do not apply or use the limits. So these are definite and indefinite integrals. So let's look into some formulae for integration. The first formula for integration, it is integration of x to the power n with respect to dx. integration of x to the power n with respect to dx. How to integrate it? The result will be, you will have to write x, then add plus 1 to the power. Increase the power by 1. That is, power is n. We do it n plus 1. You remember, in differentiation, we decrease the power by 1. Here it is x to the power n plus 1 divided by the power which you are getting here, n plus 1, plus some constant. Then this constant is represented in integration because the differentiation of constants is 0. We don't know if there is any constant associated with it, maybe 2, 3, 4, 5 something, and we cannot know whether it was present or not. So in general, this constant can be, this is a constant and it can be 0, it can be any value. This formula cannot be applied when n equal to minus 1. You have to keep this in mind. When the power becomes minus 1, you are not going to use this formula. What we should do, we'll see it in the coming formula. You can use it for any values except n equal to minus 1. So let us see an example based on this formula. The example is, the function is 2x and we have to differentiate it with respect to dx. 2x has to be differentiated with respect to dx, and there are limits 2 to 3. Remember, this is lower limit, this is upper limit. Lower limit, upper limit. Now how to use this formula? Let us do it. First of all, we'll write 2 is a constant, so it is going to come out of integration. And the integration of this part, x dx. So we can take the power of x to be 1. So it is x to the power n is 1. Power is 1 plus 1 divided by the power, that is 1 plus 1 plus some constant. So what am I getting here? 2. This is x square upon 2. So the result is x square plus some constant. This is constant. So the result is x square. The integration of 2x dx is x square. Fine. Now the next thing is, I told you this cannot be used when the power is minus 1. Now if the power is minus 1, what are we going to do? If the integration is of this form, second formula, x to the power minus 1 dx, then this can be written as 1 by x. X to the power minus 1 can be written as 1 by x dx. And the integration of this term is log e base x plus k. The formula will be, the integration of 1 by x dx will be log e base x plus k. Remember, this k is a constant. So this third formula, these formulae which I am discussing here, these formulae are the only ones which we will be using in class 11th physics. Apart from them, we have many other formulae for integration, and there are methods of integration by substitution and so many other methods. But the formulae which are exclusively applicable, useful for us in physics, them we are discussing, and this is more than sufficient for you. So you need not worry about all the other formulae which the students learn in maths. This is more than sufficient for your physics portion. Then next is e power x dx. Do you remember I told you about e power x? The differentiation of e power x is e power x. The integration of e power x is again e power x only. You are getting the same result when we integrate it with respect to dx. You get e power x with a constant. Then sin x. You remember there we talked about sin x and cos x. It's just the reverse. Integration of sin x is minus of cos x. And integration of cos x is plus sin x. Isn't it? Integration of sin x will be cos x with a negative sign. Cos x will be sin x with a positive sign. Let us do one question. Example. You have to integrate x square plus x cube with respect to dx. Let's do it here. Now for integration we can do it in parts. This is the first part. X into dx. Sorry, x square into dx. This is the first part. Plus this is the second part. Integration of x cube with respect to dx. Applying the power rule, what am I getting here? X square. I'll get x to the power n, which is 2 plus 1 upon 2 plus 1, which is 3. Plus, for this x, we have x, power is 3 plus 1 divided by 3 plus 1 is 4. So what am I getting here? X cube by 3 plus we are getting x to the power 4 by 4. If there are any limits mentioned over here, you can substitute upper limit minus lower limit. Is it clear? Yes. Can we do one more example? One more example. It is given, let it be V instantaneous. I'll write it here so that it's more visible. You got the result there. It is x cube by 3 plus x power 4 by 4. This is given V instantaneous is equal to 2t plus 3t square. This is representing instantaneous velocity of a rocket and you are asked to find the displacement. What is given? V instantaneous velocity of a rocket after launching it, and you are asked to find displacement, where it is given V is calculated in meters per second, time in seconds. V in meters per second, time in seconds. This is given in the question and you are asked to find the value of S. Now in the beginning of this episode I told you instantaneous velocity is equal to rate of change of displacement, if you remember. V instantaneous is rate of change of displacement, ds by dt. From here, can I multiply it here? We get ds is equal to V instantaneous into dt. ds equal to V instantaneous. What is the value of V instantaneous? 2t plus 3t square. I have substituted V instantaneous. ds is V dt. This V is V instantaneous. V instantaneous ka equation 2t plus 3t square we have written here into dt. This is V instantaneous into dt. So what are we getting here? If we want to get the result, S will be equal to integration of ds. If I add up all the small displacements, I will get total displacement S. So S will be integration of this side. At the same time, I have to integrate the right side also. So integration of this term 2t plus 3t square dt. You know how to integrate it, isn't it? When we integrate, we get S, which is integration of ds. Adding all small ds, I'm getting capital S. And the right side integration, I'm getting 2t with respect to dt. 2 is a constant, bringing it out. T dt, t to the power 1. It is already 1 plus 1. So it becomes t to the power 2 upon 2 plus 3 is a constant and we are integrating 3t square with respect to dt. So 3 is a constant, comes out. T square, it becomes t to the power 2 plus 1 divided by 2 plus 1. So it becomes t cube upon 3. What is it giving you? T square plus t cube. Suppose, just taking an example, if suppose t limits are given as 2 seconds to 3 seconds. I'm telling you how to use the limits. Suppose time is given from 2 seconds to 3 seconds. This is 2 to 3. How to use it? This is t square plus t cube, 2 to 3. You have to use upper limit minus lower limit. Upper limit is 3. So you have to put 3 square plus 3 cube. 3 square plus 3 cube upper limit minus lower limit. Lower limit is 2. So it is 2 square minus 2 cube. Upper limit, in place of t, put 3. 3 square plus 3 cube. This is upper limit minus lower limit. Put t equal to 2. 2 square plus 2 cube. Upper limit minus lower limit will give you the required answer. So this is how you are going to use the limits. And this is how you are going to apply the rules of integration. I hope you got it. I hope you understood this. Okay. Now, in the next class, we will be studying some of the kinematics portions. For that, you have to wait for next episode, episode 3, I suppose. And don't forget to subscribe to get timely notifications. And if you are getting the benefit from the lessons, do let me know through the comments section down below. Thank you.